The C programming language is the foundation of C++. In fact, C is the basis of many modern languages, including Java, JavaScript, Perl, PHP, Python, and many, many others. Of course, C++ and Objective-C are direct descendants of C and include the entire C language. Yes, the entire C language is included in the definition of C++, and learning C is an essential first step on the road to learning C++. Let me say this again a different way. You cannot skip this step. In order to learn C++, you must first learn C. Developed by Dennis Ritchie at Bell Labs in 1969, C was designed as an alternative to assembly language for creating operating systems, utilities, and other systems-level code. C is a small language with only 32 keywords. It's not what we would call today a high-level language. It is small, efficient, fast, and powerful. If you consider the layers of technology in a computer system as a stack, C is commonly used to write code at all levels, with its most common usage at the lower levels. Almost all firmware, almost all modern operating systems, and a great deal of application software is written in C. Why is C so popular? Systems code written in C tends to be small and fast. Well-written C can generate object code that is almost as small and fast as code written in assembly language. Code written in C is extremely portable. C was originally designed for writing operating systems. For example, the Unix operating system was written in C, and it runs on many, many different processors and hardware configurations. This is possible because so much of the operating system compiles and runs on many different machines, architectures, and processors with little or no modification to the source code. This is equally true of applications written in C. The language itself is relatively small and easy to learn, yet its simplicity is deceptive. It gives you such access to the machine that it's actually very rich and powerful language. C is a low-level language. That means that it's close to the machine. It doesn't have a lot of features, but it compiles to tight, fast, efficient code. That's what C is good at. That's why people continue to use C after over 40 years. C is an imperative language. This means that the code is described as statements. Subroutines are called functions, and arguments are always passed by value. C is a block-oriented, structured language. That is, code happens in blocks, and the blocks are structured to enhance clarity. This is to improve quality and maintainability of your code. C is strongly typed. This means that each variable must have a declared type. Type declarations are parsed at compile time, and they cannot change during the life of the variable. The advantage of a strongly typed language is that performance is significantly improved over similar dynamically typed languages. In a dynamically typed system, runtime processing power is used to determine the type of a variable and create working copies with the appropriate data structures for every variable, and even repeat these actions when a variable is changed. By determining the type of variable at compile time, all of this overhead is eliminated. The first written standard for the C programming language was a book called The C Programming Language by Brian W. Kernighan and Dennis M. Ritchie. The book came to be affectionately known as KNR, and the version of the language it documented was called KNR-C. The first edition of the book is long out of print. The revised version, currently in print, documents the next later version, ANSI-C. The ANSI-C standard was ratified in 1989 and adopted by the ISO in 1990, so you'll see it referred to as both C89 and C90. The first truly standardized C, this version is the basis for most of the C we use today. ANSI-C introduced function prototypes, void pointers, and locales, all of which are considered fundamental to C today. C99 is mostly compatible with ANSI-C, with a few new features and a few tighter restrictions. Notable enhancements include C++ style one-line comments introduced by 2 / characters, and variables can be declared anywhere within a block instead of only at the top of a block. C11 is the latest standardized version, and it codifies features that had been implemented by many compilers, including a more detailed memory model to support threaded code, removal of the gets function, improved Unicode support, anonymous structures and unions, and some optional features. This course uses C11, but since most of the changes since ANSI-C have been incremental, most of what you learn will apply to any standard C version. Because C is the foundation of C++ and the complete C language is included in the definition of C++, this course contains tutorials sufficient to learn the basics of the C language. Here's a list of chapters you may view in order to learn C from this course. Chapter 2 includes instructions on installing the environment for following the exercises, along with a simple Hello World program for testing your development environment. Chapter 3 includes an overview of the basic syntax of the C language. Chapter 4 covers the C preprocessor, an essential part of the language. Chapter 5 describes the types of data used in C. Chapter 6 covers the rich set of operators provided in the C language. Chapter 7 discusses the use of functions, and Chapter 11 covers the C standard library. These chapters will give you a thorough introduction to the language and, with a little experience, enough to begin writing C programs on your own. The C programming language is the basis of C++ and is included completely in the definition of the C++ language. Learning C is an essential first step on the path to learning C++.